Today, we are going on a bit of a journey. We're going to connect a 2,000-year-old secret note from a Roman emperor all the way to the digital fortress that's running inside your computer right now. So, let's dive in. So, let me ask you a question. What on earth could a Roman emperor, Julius Caesar, possibly have in common with the very device you're watching this on? Well, the answer is a single, incredibly powerful idea: the need to keep a secret.
And that idea has a name, of course: cryptography. It literally comes from the Greek for secret writing. And it's the entire art and science of hiding information right out in plain sight.
You know, the first attempts at this were actually beautifully simple. This right here is a Caesar cipher wheel, one of the earliest methods we know of. The idea is so basic. You just pick a secret number, that's your key, and then you shift every single letter of your message forward by that amount.
So, for example, if our secret key is 3, A becomes D, B becomes E, and you just keep going. A simple word like hello, once you run it through the system, turns into this nonsense word, K-H-O-O-R. Now, to anyone who doesn't have that key, it's just complete gibberish.
Right, but what if you don't have the key? How do you crack it? Well, the weakness of a simple cipher like this is that it always leaves behind kind of like a ghost of the original message, a pattern.
See, every language has a statistical fingerprint. In English, for instance, the letter E is by far the most common letter we use. You can see it right there on the chart, that massive spike. So a code breaker just has to count the letters in the secret message. Whichever one shows up the most is probably the encrypted E. And with that one single clue, the whole secret just starts to unravel.
And that brings us to a really crucial point. Protecting a simple secret with a simple key is an incredibly fragile system. For the modern world, we were going to need something much, much stronger.
And here's why. The scale of the challenge has just completely exploded. We've gone from trying to protect one little secret note to defending an entire digital fortress, the operating system that manages literally every single thing your computer does.
And believe me, this fortress was not built in a day. It has been built up, layer by layer, for decades. We went from just some basic networking security back in the early 90s to a real, robust security architecture in Windows 2000 with something called Active Directory. And then a huge step forward with Windows Vista, which finally stopped making every user an administrator by default. Each one of these was another brick in the wall. And this is the blueprint of that fortress. You can see it has different zones, different districts. There's user mode. That's where your apps like your web browser run. And then there's the highly protected kernel mode, the absolute heart of the operating system. Getting unauthorized access here would be like a burglar getting the master key to the entire castle. So protecting this isn't about one secret key anymore. It's about a whole complex system of rules.
And that entire complicated system really just boils down to answering two fundamental questions over and over again for every single action you take on your computer.
The very first question is all about identity. Before the system can decide what you're allowed to touch, it has to know with absolute certainty, who are you?
And it does this using something called a security identifier, or a SID. Now, I know what you're thinking. This looks incredibly complicated, right? It's just this long, intimidating string of numbers. But hey, don't worry about memorizing this. The key is understanding what it does, not what it looks like.
So, let's just forget all that complexity on the last slide. All you have to do is think of a SID as a unique, completely unforgeable digital ID card. Every single user, every group of users, even every computer on a network, each one gets one. It's basically your passport inside this digital fortress.
Okay, so the system has checked your ID card. It knows exactly who you are. The next logical question is, well, what are you actually allowed to do here?
So how does the system figure that out? It consults a rulebook. Every single object, we're talking a file, a printer, you name it, has something called a security descriptor. Just think of that as the cover of the rulebook. You open it up and inside is a discretionary access control list, or a DACL. And that DACL, it's just a list of rules. Each rule is super simple. It links a specific ID card to a permission, like read or write, and says grant or deny.
Okay, now let's see how this all comes together in practice. Over on the left, we've got a user. We'll call him Andrew. He has what's called an access token. Think of it like a wallet that's holding his personal ID card and the ID cards for all the groups he's a member of. And he's trying to access that object there in the middle.
So the system grabs the object's rulebook, its access control list, and it starts reading from the very top. And what does the very first rule, rule number 1, say? It points directly to Andrew's ID card and says, access denied. That's it. The story ends right there.
the check stops. It doesn't even matter if another rule further down the list might have granted him access, the first explicit deny always wins. Access is denied. Simple as that.
And this brings us to the central paradox of all modern security. The very complexity that makes this fortress so incredibly strong is also, potentially, its greatest weakness. You see, a single misconfiguration in that giant rulebook or one tiny bug in the code can create a hidden backdoor for someone to sneak through.
Which leaves us with a final and I think pretty crucial question. From Caesar's simple little cipher all the way to today's incredibly intricate systems, we've been in a constant arms race. But as we build these ever more complex digital fortresses, are we also unintentionally just building more doors for attackers to come and pick the locks?